Okay, this is the Professor, CBMD PhD, and today's Wednesday, October 11th, 1923. It is 5:29 and 54 seconds, a.m. Eastern Standard Time, and today's research, the Milky Way. So let's jump to it here. As finding explanation for Milky Way's warp, astronomers' results bolster a hypothesis of how galaxies evolve. Date October 10th, 1923. Source: Harvard University. Though scientists have long known through observational data that the Milky Way is warped and its edges are flared like a skirt, no one can explain why. Now astronomers have performed the first calculations that fully explain this phenomenon with compelling evidence pointing to the Milky Way's envelope in an off-kilter halo of dark matter. Our galaxy is located inside a diffuse cloud called a stellar halo, which extends much farther out into the universe than groundbreaking work published last year. The research team deduced that the stellar halo is tilted and elliptical in shape, like a zeppelin or a football. And building on that, the team assumed the same shape for the dark matter halo, the larger entity that encompasses everything in and around the Milky Way. Dark matter makes up 80% of the galaxy's mass, but is invisible because it doesn't interact with light, so the shape of that halo must be inverted. Using models to calculate the orbits of stars within a tilted, oblong dark matter halo, the team found a near-perfect match to existing observations of a warm, flared galaxy. A tilted dark halo is actually fairly common in simulations, but no one had explored its effects on the Milky Way. It turns out that the tilt is an elegant way to explain both the magnitude and direction of our galaxy's wobbly disk. If the galaxy was just evolving on its own, it would have had this nice spherical halo. So the fact that the halo is tilted and has a football-like shape suggests our galaxy's experienced a merger event when two galaxies collide. The calculation of dark matter halos' probable shape may also provide clues as to the properties and particle nature of dark matter itself, which remain unsolved mysteries in physics. The fact that the galaxy is not spherical in our data implies that there is some limit to which dark matter can interact with itself. As confidence in these findings might lead to better ways to cleverly study the unobservable dark matter that makes up most of the universe. This includes new ways to pick up on kinematic signatures of dark subhalos, which are miniature dark matter halos zipping around the galaxy. And this is the Professor of Space Technology, Astronomy, Advanced Physics, Mathematics, Computer Science, and Laser Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.